So for cyclohexane, so not this is not cyclohexane, sorry, for hexane. So I was explaining that we expose this hydrogen, then we have CH2 there, followed by CH3 there. So we have this is attacked by one radical chlorine. So we have a molecular cleavage here. Hydrogen takes a arrow, carbon, hydrogen takes, no. Sorry. That is not correct. That is not correct. That is not correct. So we have H here, like that. So carbon takes the electron it contributed, half arrow, like that. Hydrogen does the same, however, it brings its one electron so that it joins with that of chlorine. So this H and that is hydrogen chloride. And I think it is the illustration that I have here. Yeah, it is this illustration that I have here. So I have my radical of chlorine from the first reaction. Then my hexane, I expose the hydrogen from the site that is reactive. So carbon takes the electron contributed like that. Hydrogen does the same, however, it brings its one electron so that it joins with that of chlorine. As a result, we form this radical and the hydrogen chloride. We form that radical hydrogen. Then, in the next step, a new chlorine, ClCl, combines with this radical that has been formed, CH3, CH2, CH with a dot, CH2, CH2, CH3, like that. So that is what we are having. So chlorine takes the electron contributed. This also does the same, however, it brings its one electron so that it joins with that electron of the radical. Therefore, we form our 3-chlorohexane. We form this as a major product. We form this as our major product from the combination of one radical, a new chlorine, and the radical, the alkane. Therefore, in this case, we synthesize our 3-chlorohexane. I am calling it 3-chlorohexane because chlorine is attached to position 3. Yes. Then this reaction also results in formation of a radical of chlorine. Then the reaction is terminated by recombination of such radicals. So that radical that has been formed combines with, so this one is from this step here. Then this other one is from the first step. So they combine to form chlorine so that the reaction is terminated. So the reaction is terminated. Now, that is the reaction with the halogens. The reaction with halogens. Let me try to lower down this font a bit. So that is the first reaction. Then the second reaction, we look at how that compound reacts with the nitric acid. We look at how it reacts with nitric acid. We are lucky that one reaction has been explained. For the reaction with nitric acid, I'm going to start in the same way as I started. I start with an example of methane because these things have been explained. So if I have methane reacting with nitric acid, don't forget that this reaction occurs when nitric acid is in vapor phase. If nitric acid is not in vapor phase at 300 degrees Celsius, no reaction. No reaction. Yeah, so it is vaporized nitric acid, or one may look at it as gaseous nitric acid. So here we said that, if you remember very well, we said that nitric acid from bonding, we are able to explain that nitric acid has this formulation. Yeah, nitric acid, we can write it in that form. So you see, if I write it in this form, the alkane methane in this case loses a hydrogen. Methane in this case loses a hydrogen, so that methane, I am on methane. So if methane loses hydrogen, then I'm left with CH3. Then this, you see, nitric acid, this is how I can write it. Then one part, which is NO2, comes here. Then the other part, HO, combines with the hydrogen that was lost by the thing to form water. So this reaction, we saw that it results in formation of compounds known as nitroalkanes. So in this case, we have the same thing. So hexane reacts with nitric acid. Hexane reacts with nitric acid in vapor phase. Reacts with nitric acid in vapor phase at 300 degrees Celsius. Reacts with nitric acid in vapor phase at 300 degrees Celsius in a nitration reaction. It was a nitration reaction. Reacts with nitric acid in vapor phase in a nitration reaction to form. As I have explained earlier on, it may be very difficult for the start to know the name of the product. Why am I saying so? Because the product you obtain it, you see it clearly after outlining the mechanism for the reaction. Yeah, so the name of the product can come later on. So to form three, why three? I am from explaining that position three, I'm from creating a clear distinction between the kinds of hydrogens that are within hexane. Hexane has primary and secondary are more reactive. So in this case, this is what I have. Then I outline the mechanism for this reaction. The mechanism still starts with chain initiation, where we write our nitric acid in this form. If nitric acid is demonstrated or written in this form, this oxygen takes the electron it contributed. Nitrogen does the same like that, and when they take those electrons, we shall form hydroxyl radical and a nitro radical like that. That is step one, chain initiation. Now step two, now that I know my carbon that is more reactive, for step two, the hydroxyl radical attacks the alkane. This is step one, the one you are seeing here down. That is step one. Step two, the hydroxyl radical attack the alkane. So I have my hydroxyl radical, HO with a dot, followed by my alkane. My alkane is CH3, CH3, CH2. Then I expose the hydrogen at position 3, like that. Followed by CH2, CH2, and finally CH3, like that. So this carbon takes the electron it contributed. We have seen that already. Hydrogen does the same, however, it brings its one electron so that it joins with that of hydroxyl. These arrows are supposed to make one curve, and it is what I've done here. You see, it is what I've done here. Yeah, here I'm just trying to illustrate. So carbon takes the electron it contributed, hydrogen does the same, however, it brings its one electron so that it joins with that of OH. As a result, we obtain this radical. And in the final step, the reaction is terminated when this radical combines with the nitro radical, from step 1, and it is this illustration here. So they combine, they share that electron so that we form 3 nitro hexane, so that we form 3 nitro hexane. And that marks the end of the 2 reactions. What are the 2 reactions that have been of interest? Halogenation and nitration. Halogenation and nitration, we have outlined the mechanism for each. For each, we have outlined the mechanism, and also the equations have been given clearly and explicitly. Yeah. So what are we now left with? So synthesis, we started with synthesis that was dissected clearly. This is our map. This is our map. This is our map. So we started with synthesis that has been done. We have done mechanism clearly. So I want to go to physical properties. I'm left with 2. I don't know what should follow the other, but I have physical properties not attempted yet. EA, application, danger, and mitigation. So in the next section, let me come back with the, I think I should come back now that we know compound A, compound B, and compound C. Oh, we should come back with the, I don't know, we are going to